Hi, welcome to PhysiClant's channel. Today, we are going to discuss about projectile motion. Without further ado, let's get started. A projectile is any body that is given an initial velocity, and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. A batted baseball, a thrown football, and a bullet shot from a rifle are all projectiles. The path followed by a projectile is called its trajectory. Projectile motion is always confined to a vertical plane, determined by the direction of the initial velocity. Look at the figure 1. This is because the acceleration due to gravity is purely vertical, or we can say that gravity cannot accelerate the projectile sideways. Thus, projectile motion is two-dimensional. We will call the plane of motion as the xy coordinate plane, with the x-axis horizontal and the y-axis vertically upward. We can then express all the vector relationships for the projectile's position, velocity, and acceleration by separate equations for the horizontal and vertical components. The components for the acceleration are x for the horizontal component equals to 0, and y for the vertical components equals to -g. This condition is used for the condition of no air resistance. Before we proceed, I would like to expose to all you guys the equations of motion with constant acceleration. There are total 4 equations for them. Equation 1, final velocity, equals to initial velocity plus acceleration multiples with time. Equation 2, final position, equals to initial position plus initial velocity multiples with time, and plus 1/2 multiples with acceleration and time, power of 2. Equation 3, final velocity, power of 2, equals to initial velocity, power of 2, plus 2 multiples with acceleration, and in a bracket of positions difference. Equation 4, positions difference, equals to 1/2 multiples with time, and in a bracket of initial velocity plus the final velocity. However, you might change all the units in each equation, depending on some circumstances. Since both the x acceleration and y acceleration are constant, we can use equation 1, 2, 3, and 4 directly. Suppose that, at time t equals to 0, our particle is at the point x0, y0, and its initial velocity at this time has components v0 x and v0 y. The components of acceleration are x equals to 0, and a y equals to -g. Considering the x motion first, we substitute 0 for x in equation 1 and 2. Then, we might get these equations. Next, for the y motion, we substitute y for x, vy for vx, v0 y for v0 x, and a y equals to -g for x. Figure 2 shows the trajectory of a projectile that starts at, or passes through, the origin at time t equals to 0, along with its position, velocity, and velocity components, at equal time intervals. The x velocity, vx, is constant. Meanwhile, the y velocity, vy, changes by equal amounts and equal times, just as if a projectile were launched vertically, with the same initial y velocity. In this case, if air resistance is negligible, the trajectory of a projectile is a combination of horizontal motion with constant velocity, and vertical motion with constant acceleration. At the top of the trajectory, the projectile has 0 vertical velocity, vy equals to 0, but its vertical acceleration is still -g. Horizontally, the projectile is in constant velocity motion, means that its horizontal acceleration is 0, so it moves equal x distance, in equal time intervals. Vertically, the projectile is in constant acceleration motion, in response to the Earth's gravitational pull. Thus, its vertical velocity changes by equal amounts, during equal time intervals. Let us look at the condition, where we consider the angle of trajectory, into our calculations. Here, we can represent the initial velocity by its magnitude, v0, as the initial speed, and its angle, alpha naught, with the positive x-axis. We can depict it from figure 3. In terms of these quantities, the components, v0 x, v0 y, of the initial velocity are, v0 x, equals to v0, cos, alpha naught, and v0 y, equals to v0, sin alpha naught. Figure 3 shows a trajectory condition during kicked soccer ball. The initial velocity components, v0 x, and v0 y, of this projectile, are related to the initial speed, v0, and initial angle, alpha naught. If we substitute equation 5, and 6, into equation 1 through the 4, and set x0, y0, equals to 0, we get the following equations. They describe the position and velocity of the projectile in figure 3 at any time, t. To find the position, we need to use equation 2. From here, we can substitute equation 5, and 6 according to the specific axis. From the figure 3, it depicts the initial position of the projectile. So, firstly, to get the x-coordinate position, we take x0 equals to 0, and lay x equals to 0. Substitute equation 5. Then, we get equation 7. Secondly, to get the y-coordinate position, we take y0 equals to 0, and a y equals to negative g. Substitute equation 6. Then, we get equation 8. However, to find the velocity, we need to use equation 1. So, thirdly, to find velocity at x coordinate, we take ax equals to 0. Substitute equation 5. Then, we get equation 9. Fourthly, to find velocity at y coordinate, we take a y equals to negative g. Substitute equation 6. Then, we get equation 10. Yeah, here we go. We can get a lot of information from equations 7 through 10. For example, the distance, r, from the origin to the projectile at any time, t, is r equals to the third of x power of 2, plus y power of 2. This distance equation is simply constructed by using Pythagoras' theorem. We replace a c with r, and a with x, as well as b with y. It goes the same in finding the magnitude of projectiles, speed, which is v equals to the third of vx power of 2, plus vy power of 2. Okay. Now, however, to find the direction of velocity, we can use the basic trigonometric function, the tangent ratio. Tangent equals to opposite over adjacent. In terms of the angle, alpha, it makes with the positive x direction, as in figure 3. Then, we get tan alpha, equals to vy over vx. Nah, it's not that hard. Chill. Okay, that's all for this video. I hope you guys understand. See you, stay safe.